let's go ahead and get started with the next team so that we're a little ahead of schedule. We have ProxSeat and we're here already.
All right, howdy everybody. Thank you so much for coming out to listen to our critical design review today. And we are ProxSeat and we're going to talk to you about our capstone project, which is the EliteSeat. So today I'm going to we're going to have this roadmap for our presentation. We're going to start with the introduction and background of our project, go over some of our project deliverables, and then we have our conceptual block diagram, which is going to give you a better idea on how we're actually building this. And then the rest of my team is going to go into the details with our software, electronic, and mechanical overview. We have a short video demonstration for you guys to show our working prototype as it is currently. And then we're going to go into our project status, contribution, and finances as they are currently up to date. And then we'll wrap it all up at the end and go back over what we talked about. So first I'm going to introduce you to our project and my team. I'm Madison Collier and I'm the project manager.
I'm Christopher Smith, I'm the hardware engineer.
I'm Riley Purdy, I'm the software engineer.
And I'm David Bob, and I run systems integration.
We'd like to give a thank you to our faculty advisor, Dr. Michael Okwan, and to our industry sponsors, TD Industries. So there are three main problems that we wanted to address with the conception of the EliteSeat. We wanted to address human factor, automation, and health concerns as they apply to the live entertainment industry. So when we're talking about the human factor, we want to address confrontation over assigned seats. So when you're going to football games and concerts and there might be people sitting in your seat and you start getting negative feelings, you might have hostility, and that's overall putting a damper on an otherwise really fun evening for you and your friends and your family. And then that can also lead to increased expenses to employ people and on the stadium side. So stadiums are having to pay more money to have more people on staff to resolve issues like this with assigning tickets and working with these issues. We also wanted to address the lack of automation in the live entertainment industry. So a lot of industries currently are moving towards automating their systems with manufacturing and other things. And with live entertainment, you don't really see that same progress. So we wanted to help start that and get the ball rolling. Lastly, we wanted to take a really present day look at this. So with the effects of COVID-19, we have where we're having to social distance and we can't have events like this. But with live entertainment, you have people who are out of jobs and they're losing money. So we're hoping to help increase their profits for the stadium so stadiums can keep people employed, and overall we have more events so we can get back to our new normal. So with our EliteSeat deliverables, we're going to have three main things. We're going to have the NFC assignment unit, which is going to consist of all of the programming and software necessary for this project to work. We're going to have our actual seat locking system, which is going to be modular, so it can be attached to any certain type of seat. And then we're also going to have different variations of NFC writable tags to show that this is something that can be implemented regardless of what specific type of NFC you're using. And we can talk more about that in our overviews. Our final demonstration for our sponsor is going to be April 28th, 2022. And as of right now, that is our hard deadline for a successful prototype. And now I'm going to hand it off to my team to go into our project specifics.
All right. So for our project, we were actually able to obtain 2 seats from Kyle Field before it was renovated, which is pretty cool. Pictured here is one of those seats. So for the conceptual block diagram, what I'm going to do is have different angles of the seat to highlight the different subsystems of our system. And at the end, I'll have a full view like you see on the left-hand side with the full system implementation. Right here is a seat back. On the upper right-hand corner is going to be our NFC reader. So this is what's going to allow the user to present their NFC tag, and if it's the correct one, it will unlock the seat. And right here you have the LED lights, so that's going to be an indicator to the user. So we're going to have it programmed where it'll be red LED if it's locked, green if it's unlocked, and yellow when it's unassigned and allows for maintenance. This is the bottom of the seat. So what's good about these chairs, and if you go back a slide, so the back, this plastic piece right here, and then this piece right here, they unscrew, so they're very accessible. So for this seat, what we're able to do, underneath this plastic piece is a piece of plywood that separates the plastic seat and the seat cushion that the person sits on. So what we're able to do is mount our system onto that plywood and cover it back up with this plastic to help keep it safe from weather and like spilt beer or something that people spill on it. So that's what's good about this design. So here we're going to have our power supply. It's 2 9-volt batteries in series for 18 volts. And it's going to feed our Pico microcontroller. On the right hand side here are the lines that come from the LEDs and the NFC reader. On the right, we have a limit switch, and on the left, we have our locking solenoid. So what happens is when the user presents the correct NFC tag, it's going to send that data to the Pico, at which point it's going to send power through a relay, which will unlock our solenoid to allow the user to hold the seat down. When the seat is down, our limit switch will be able to tell the system which position the seat is in. And these are just different angles of the chair. So on the left-hand side here, you see this bracket. That's where we're actually going to drill a hole to have this solenoid locking bolt go through. So that's what's going to physically hold the seat locked. The limit switch that I was just telling you about is important for our coding because our system needs to be able to tell whether the seat is up or down. For instance, if a person gets up, and Riley will talk about this in a little bit, when a person gets up to say, let someone pass by or cheer for a touchdown or something like that, we will have a delay so the seat doesn't automatically lock, but the seat needs to be able to know what position it is, the position it's in. And finally, here's what I was telling you about the full view. So this is the entire system implemented on our chair. NFC reader up on the top, LED lights are on the top as well. And the wires, what we're going to do, as I said, we can remove that plastic back and then this plastic here on the bottom. We'll be able to run the wires down the back of the chair, through the armrest, and then into the seat. So we actually, besides drilling the holes on the brackets, we're pretty much keeping the integrity of these chairs, which is pretty cool because they're kind of collector edition, old Kyle filled seats. So, yeah, so now Riley will go over the software.
So the first main component of our software design is the central assignment unit. This is a Python script that's originally designed in Ubuntu Linux, but can be run on any type of operating system since it is a Python script. Basically what this will do, the vendor will create an Excel spreadsheet with the NFC section, row, and seat information, as well as the NFC IDs that they assign. And the script will first turn this database into a pandas database, which is easily manipulable by Python scripts. And this right here is a sample of the graphics user interface that will launch upon the program's start. That will allow the vendor to enter in the section, row, and seat information. And using a USB NFC tag reader that David will talk about in the electronics overview, you can assign an NFC tag such as this to have an NFC ID. Right now it's just a randomized number. And using this, you can go on to the EliteSeat lock itself. So starting out when the seats turn on, it will be originally a red indicator indicating that it's off. And when the user or master key is detected, the device will unlock and turn green for about a minute. And using the limit switch that Chris talked about, it will check to see if the seat is open or closed. And if the seat is closed for over 1 minute, it will lock again and turn on the red LED. At this point, if the master key is detected in the case of a lost tag or any technical issues, the device will permanently unlock and stay unlocked for the duration of the event until the master key is once again detected. Once it's in this troubleshooting mode, the little LED will turn on and indicate that any troubleshooting that needs to happen can happen without the seat automatically locking. If the user NFC tag is detected at any point as well, the LED will turn green and start operating again as usual.
Alright, so now I will go over both the electronic and mechanical overviews. These will consist of the specific components that we chose and why we chose them over others. So starting here off at the microcontroller. So very first decision we had to make from the very beginning was, do we go with a microcontroller or do we go with a single board computer, such as a full Raspberry Pi or even an FPGA board as well? There's no doubt that those devices will give us a lot more functionality. However, it gives us too much functionality for what we need to accomplish here with our project. So with that decision made, we went with the Raspberry Pi Pico, which is centered around the Raspberry Pi 2040 microcontroller. It's actually the first microcontroller they made. We looked very hard at the Arduino family of products. It's a very strong competitor, they're very capable. However, the main selling point between the Pico and Arduino really boiled down to the programming languages involved. So the Raspberry Pi Pico uses Python derivatives, while the Arduino uses C++ derivatives. And to be absolutely blunt, we vastly prefer to work with Python derivatives. So we also looked at the STM32 family of products. In our design phase, which was several months ago when we were doing 419, there were availability issues along with cost. So they were considerably more expensive than the Raspberry Pi Picos. All right, so moving on to our tag receiver, our NFC tag receiver. We elected to go with the RC522 card sensor module. And honestly, this is a bit of a no-brainer. These things are cheap, they're reliable, they're readily available, and there is a ton of documentation and proven project use over the years. So we did examine the PN532 module as well. Now this module is a more modern chipset with more capability and supports more RFID protocols. But again, for the functionality that we are shooting for, it just simply wasn't needed. And so each one of those 532 modules is also approximately about 3 times the cost of the 522. So moving on to the NFC tag scanner now. We elected to go with the ACR 122 card reader. So in all reality, there's not too much variation in the different products of this type. It really boils down to what kind of form factor you wish to have it in, and what kind of connection type you wish to have with it. So with this one here, you can see that it already comes encased, fully assembled in its own plastic case, and it also has a USB type that we can directly interface with our PC. The Micro 1726, for example, however, is a very bare bones board. It's not assembled, it doesn't come with its own case, and it doesn't even have a connection type set up. So again, it's kind of a no-brainer for us to go ahead and move with the ACR 122. Okay, so now for our electrical mechanical control relay. We elected to go with the 5-volt DC single channel relay. It's kind of it's kind of a no-brainer. It's kind of a theme here for these different components. The only real option that we had other than that was to build a custom power design using a MOSFET as a switch. When we broke it all down, and we actually did develop one, however, all of the design options that we built into that PCB was already built into this relay board in a form faction that simply could not be made any more efficient. So it was a case of trying to reinvent the wheel, and we just simply didn't need to. Okay, so then now we move on to LED light indication. So we have chosen for now to go with the Adafruit Neo Pixels. These are incredibly versatile little LEDs. You can, with it, the user can control any depth of color that they need and any pattern that they want. So the other option was a very simple LED board that just had a traffic style light setup, which would just be a red, yellow, green in a row. A very simple board, and it is still considered a strong backup option just in case. Okay, and now for our adjustable roller limit switch. So this was actually a great find by Chris, because I originally was doing the momentary push button. So as you saw with the pictures, we are not working with flat surfaces. They're curved, they're at different angles, and so being able to use a roller type of switch would give us a lot more flexibility in order to be able to update our Pi Pico. So the momentary push button just has a very simple little lever, which is not very flexible with our design, both literally and figuratively. And now that will lead us to our last component, which is going to be our locking solenoid. So there has been a major change with this. So I'm going to show you a small demonstration video that actually uses our push-pull solenoid. So early on in our design phase, that was deemed to be more than adequate for what we needed, and it actually is. However, as we worked through the process, we have found a newer style, which is going to work far better with our design. It's a door latch style. So instead of just having a cylindrical plug, it's actually going to be like an actual door flapper style, which will work far better with our design. So mechanically speaking, those two devices are identical. And so for now, that's why I decided to go and just keep the push-pull solenoid up as our main until we get our hands on the door latch style. Okay, so I'm going to show you a quick little video of our demonstration. So what's going to happen is I am going to activate the card reader here with the NFC tag, and then that is going to go through our Pi, do the relay, and it's gonna activate the solid array. Alright, and again, just to reiterate, again, will be replaced. We currently have that part ordered and should be expected within the next couple weeks. Now I'll get back to Matt for project status.
And now we're just gonna go over all of our project updates up until this point. So here I've broken it down into the four main portions of the project. The software, as Riley touched on, our CAU is currently finished. The EliteSeat program is waiting to be interlocked with the hardware that we've ordered. So with the hardware then, all of our components have been ordered and have been tested, except for our 2 new changes. So we're waiting for those to come in, and those will be working as well. And with that, we have our testing plan developed as well for future application. So we've gone over and decided all of the bugs and issues that might come up when using this project, and we'd like to go ahead and address those and get those worked out before our final demonstration. So again, as I've already touched on, all our necessary components have been purchased, and any last components other than our flapping style door lock is not design critical. And here I have a breakdown of our contribution with our labor hours. So as you can see with our STP estimate, we estimated we need about 1,100 hours. As we've gone through this project, we've actually been able to reduce it down to 900 hours since we've been able to swap out some components that are just more efficient for us. And I've broken it down here by team member, our predicted hours per week, the actual, what we think we'll need next week, and then our cumulative totals. So taking our cumulative total with our estimated remaining labor of about 300 hours, we're looking at a minimum 44 hours per week in order to meet that hard deadline that I discussed earlier in the presentation. And here I have a graphical representation of where our finances currently are. We were given $2,000 from our sponsor. We spent about $720 thus far. Our estimated remaining expenses for parts that are still coming in is about $100 or so, and this is not including shipping. And you can see here, so our prototyping phase, which was completed during 419, we spent about $250, and we're pretty much on track with our actual build in this final semester, nearing that $700 mark. So again, the goal of the EliteSeat is to build a smart modular locking system for seats in particular. So all of our constraints have been finalized, and we've established all the parts that we wish to use for the success of this project. We're currently on track and on budget, which is always a plus. And then all that we have left is the integration and rigorous testing before our final documentation and demonstration to our sponsors. And with that, I'd like to say thank you guys for listening. We really appreciate it. And of course, we'd like to give another shout out to our technical advisor and our sponsors. And if you guys can go and use this QR code and leave us a review on the CDR, we'd really appreciate it. Now I believe there's time for questions.
We have about 5 minutes for questions.
Let me get the question started. First of all, thank you for leaving back about $1,000 for other capstone. Okay? And that's what happened when you leave. You don't spend all of your budget for external sponsors. Okay? So thank you for that. Now, do you have all the parts that you will require? Because one part is being ordered now. Do you have pretty much? You will have everything that you need.
This past week, I placed the last PO of all the necessary design parts we need. The last things that I might order in the next week after spring break is just the different types of NFC tags, because like Riley showed, we have stickers and we have cards that came with the other ones, but we want to show that this is a very versatile design, and regardless of what type of tag you can use, it will be successful and that it is integratable across multiple different applications. So.
And your project is pretty, I would say, close to something that could be marketed, okay? What are your competitors, or what are the devices that you're competing with for in this market?
So right now, the only competitor that I found is a brand called WavePass, but I haven't even found that they've been an actual brand. They just have a patent registered, but they don't have anything on a locking mechanism or system for actual seats. Theirs is just automated tickets, and they haven't updated their IP rights and any of their patents since 2015, and I haven't been able to find anything on the internet. So right now it looks like we don't have too many main competitors. Of course, there's always more that I'm probably not accounting for, but if you can think about when you go to stadiums, that nothing like this has been implemented yet. So Currently, our biggest competition is just getting the interest and garnering the interest and proving that this is something, like you said, that is marketable and applicable to stadiums all over the world.
You guys are probably getting some of my easiest questions for the day, but it's just because of the advanced nature of your project as well. In terms of, so therefore, the market is wide open, okay? Do you guys have any plans to convert this into an actual product that you can sell?
So I have personally been working with Chris so everything that we're making here, this is prototyping.
Mhm.
We have already been discussing ways that we could upscale it to, several hundred thousands of units. And that is something that's a discussion that's currently ongoing. And so yes, we are very cognizant of that. And that, if you notice, actually, as I was going to the components, cost was a major part of most of my considerations. And that is due in part to the factors of scaling up to, like I said, multiple hundreds of thousands of units at a minimum.
Okay. All right, and my last comment, I know that your technical advisor is here as well. Are you guys registered for the Engineering Project Showcase?
I started the application.
It's not a trick question, just say yes or no.
No.
All right, that's okay. What I would advise you to do, and I'm encouraging every group that you could actually think about patenting this, okay? The University of Resources for that will guide you through a commercialization unit. You can get in touch, you can contact me, I can lead you to some of the information. And this is something I think you guys should think about, okay? All right, and I'm not just favorite, you're not my favorites or anything like that. Everybody is my favorite, but I think that this is something that you can, convert.
Last semester, I actually did talk to a patent lawyer about this, so I have been in contact, and like David said, we're all pretty cognizant of the marketability of something like this, but currently as students, we haven't really approached a startup idea of it yet, but that might be a conversation we all have closer to graduation.
There are lots of opportunities for you, and it may be easier for you to do that while you're a student than after you graduate. It may be cheaper, because there are a lot of opportunities.
That would definitely be better.
University will support you. Okay. All right, that's it. Tougher questions, guys. Some tougher questions.
I know you're developing this for TV Industries. Have they approached you with any idea to implement this with like Apple wallets or whatever wallet is the wallet standard for Androids? Have they like talked to you about it?
So
And was it a design constraint that was important to them?
So they've mentioned it. It's not in the scope of this project since it's only 2 semesters long, and getting the rights to program an NFC wallet item is kind of extensive. Sometimes the process takes longer than what the capstone project allows. It's definitely something that we've looked into for the future of implementation, because it would definitely be easier than handing out stickers. On the same side though, we'll also, if we do scale this up, planning on working on ticket vendors such as Ticketmaster, so when you get your tickets in the mail or handed to you when you show up to the event, you'll get a sticker or a bracelet or something like that. I've been to a few concerts to where they have LED light-up bracelets, so if we could integrate that into the bracelet as well and make it one big package, that would be a good idea as well.
Okay. Yep.
Why can a phone not be used to be programmed to set that frequency to act as the chip?
Oh, it definitely can. It's just the timeline.
It's
Okay.
not in the scope of our project, but it's definitely something that's feasible. I mean, you see it every day when you use Apple Pay and you use NFC technology. And it's definitely something like Truth had brought up, TD has brought up to us with the VP of marketing when we talked to him about it. And it's something that would make our project much more marketable in the future. But again, for the scope of our current project, we'd like to look at more physical tags. And if you want to think about it more realistically, you would have to rely on your phone not dying when you're at an event. And sometimes people forget chargers. So a phone would be added to a multiple resource type of feel, which is what I talked about. I'd like to have different type of NFC tags. So Riley has a sticker. We could use a phone. You could use a bracelet. So we want there to be multiple different options for consumers that will work best with their budget, their schedule, their lifestyle, however you'd like to put it.
At the end of the day, we want to be as adaptable as we can. So right now we're using batteries. Maybe one day we'll be able to plug it into an actual outlet. We want to be as flexible as we can with our technology to where we can market it to everyone.
That's all the time we have for questions.
All right, thank you guys so much.
Appreciate it.
All right, next up is TJCC Mobile.
Wait, what?
It's not a new schedule.
Oh, no.
Yeah. This is, yeah.
Go ahead.
Thank you, appreciate it.